evening everyone. This is Amit. In previous class we have discussed about the idea of current, concept of current in conductor, what is the bandwidth, what is conduction band, what is free electron, what is valence band. We have discussed what is resistance and many varieties of questions we have seen. We have done some question from Pathfinder, we have done some question of my own creation. Some in upcoming class we shall discuss those questions also, and I have given one question as a homework to you also. Then and now we are going to discuss what are the factors which can affect the resistance. So, and maybe in upcoming class we will discuss how conductivity is tensor quantity. If you are aware of this, what I am saying, then you might know what I am talking about, and if you are not aware of this, then we'll talk about it. And if you have ever noticed that in books they are considered as scalar quantity. I might have told you in previous class also, but in upcoming class we'll talk about this on length, what is tensor and what is matrix and all. Maybe after completion of chapter we'll start a little bit higher order calculus for those who are interested in higher level physics like Olympiad or something, that then we will discuss that part. So today we are discussing factors affecting resistance or resistivity. For everything we can discuss. Let's talk about first resistance, then we will talk about resistivity. See, we know that resistance formula is pretty basic. We have studied from 10th class that it is rho L by A, where your L represent what? This is the basic idea, that this is your L if the connection is like this, and area is this cross-sectional area, right? We have talked about this on length, and then we can see the resistance simply depends on dimensions of the conductor. So it is very obvious that it is going to depend on L and A, and we have seen the effects. So we are not going to discuss about this, that is because that is very basic. We are going to discuss how resistivity will change if we maintain L and A constant. Got it? We are going to discuss that part. So, if you remember, we have discussed the generalized formula of resistance also and generalized formula of resistivity also. I will give you a bit of short recap. That we have discussed current is drift velocity times electric charge of electrons, and N times A, where N was free electron density. Free electron density, right? And A is your area. And what was the drift velocity formula? If you remember, what was the drift velocity formula? We have defined drift velocity with the help of what? One formula was drift velocity, mean free path, by average relaxation time. If you remember what was average relaxation time and mean free path, I will give you a little bit of recap because we haven't been a little bit not so frequent after the last class. So I will give you the quick idea what was average relaxation time. So we remember, do you remember that in a conductor you will have what? Kernels. This is the very old theory. These are the kernels, and if it is connected to a battery, then what will happen? We know the temperature of the conductor we are taking to be higher than the 0 Kelvin. So the electrons are going to have the thermal energy, little bit of thermal energy is going to provide little bit of kinetic energy, that means they are going to move randomly. So electrons are going to do random motion, plus because of battery electrons cannot get accumulated at any point, that means there will be no induced electric field due to the conductor or the accumulation of electrons. So electrons are going to move in a certain direction also. Doesn't mean it will move in a straight direction, but it will move in a very arbitrary random direction. Still it will make some significant change that we have discussed. And if you remember, these are the electrons, and these any electron will experience force. That force will be what? Q times E, and it will be negative not because the electron has negative charge, or you can say that also, but because the force will have opposite direction of electric field, and we can replace Q with what? E. We remember, and because of this electric field, electron is still doing the random motion. It is still doing the random motion. Each electron is doing random motion, but just because of battery it is experiencing little bit of extra push, which will make it net of non-zero displacement. So because of this electric field, you can say if this is the electron, it is going to move in very random direction. It will collide with many kernels, and with that many kernels still it will move in opposite direction of electric field. The velocity, the average velocity by which it will move in direction opposite of electric field, the average velocity by which it will move in direction opposite of electric field, that velocity is known as drift velocity. And the random motion is caused by what? Because of the random motion is due to what? Is due to thermal energy, right? So still there is thermal energy, but because of battery it is feeling little bit of extra oomph, that is pushing it in opposite direction of electric field. That was your drift velocity. And if there is no conductor, the average, if there is no battery, the average velocity was what? 0. Remember? So just because of battery, the net velocity is coming out to be not 0 this time, and this non-zero velocity is giving you what? The current. So electron is going to move in this direction, so that means current will move in opposite direction. Because the theory of current and the electrodynamics was introduced way earlier than the discovery of electron itself. So later on we have decided that current will still remain the same direction, so it will not create that big of a mess. So we remain these convention that current will flow in opposite direction of electron. And you can see electric field is going to be constant because we are going to assume that potential difference across the battery is constant, and if we assume the length and area is constant, that means electric field also will remain constant. That means force experienced by each electron is going to be constant, thus acceleration is also constant. So it can be simply derived. See, I am giving you the recap. So it was simply derived. What? For each electron it was simply derived. And tau 1 is what? It is tau 1 is what? It is the time taken between each successive collision. So for single electron, let's say the time taken between is tau 1, and so on. You can write it will be V2, U2, and acceleration will remain same, tau 2, and so on. We can write this will be your what? Vn, and this will be your what? And if we calculate the average, that's how we calculate it. If we calculate the average, this is the symbol of average. If we calculate the average, that average is known as drift velocity. and that average I can write it like this: U1 plus U2 plus U3 up to UN over, and with no battery the average velocity was 0, and here you can take a common, here tau 1 plus tau 2 up to what, tau 1 over n. If you simplify, this will give you 0, and this was what, a is your what, minus e by I forgot to write type, sorry, nothing. So E by here. Force is this. So acceleration I shall write here. Acceleration what will be what? Force by mass. So it will be E by mass of electron. So here you will have mass of electron, and here you will have tau average. So that was your drift velocity, where minus represent what? That minus represent what? That the direction of drift velocity will be opposite of electric field. Right? This is what we have discussed so far. And now we are going to talk about factors affecting resistance. So I have given you the generalized formula of resistance. I'll tell you how. I'll give you again the recap of that. So this formula can also be changed into what? If you know, electric field is what? Minus delta V by L. Right? So you can replace it, you can have, if you want to put modulus, you can also write like this. That was the idea. So you remember something from 10th class? So we can say, if you remember Ohm's law, if we have this conductor, potential difference across this is 0. So we can say delta V equals to IR, that is very basic, you all should know, and equals to what? R. So R is simply what? Delta V by I. It seems that delta V resistance depends on delta V and I, but it does not depend on delta V or I. It actually is independent of that. We can get the delta V from this formula. Delta V will be just what? Simply drift velocity times mass of electron times length divided by E and tau average. Right? You can paste that formula here, delta V. So we right, and your I, we have seen that I can be written as, where is I have written V now, right? So you can see your I can be written as what? I can simply write V now. So in here, instead of I will write what? V now. Right? Cancel out what you can cancel out. What you will left with, drift velocity will get cancelled out, and mass of electron will remain there, and you can see electron will get square. So it is what? Mass of electrons times L. Here you got P square N A. Right? This will be your R. Check it, MEL over E square, and I forgot to write tau average. Right? This is your generalized formula of resistance, and you can see resistance depends on what? Mass of electron is constant, right? And E square is also constant, because mass of electron will remain same, and charge of electron will also remain same. These are constant term. So the only variable we have what is free electron density, area of cross section, length, and tau average. And these factors are interlinked to each other, right? And from here you can also get it, the idea of resistivity will be your what? You just separate the L by A, it will be mass of electron times E square and and then tau average. This will be your resistivity, right? So we are going to talk about the effects of factor affecting resistance, and this was the quick recap of all the concepts we have studied without the practice question we have done, right? So there on, if we want to discuss about resistance or resistivity, whatever you want to discuss, how we are discussing, see, again, factors of affecting resistance. You can write resistivity also, because actually we will discuss resistivity also only. Why I said this? See, so first and foremost we will discuss the simplest case which you will see in every book. The simplest case is, here we will take the assumption. What is the assumption? There are two assumptions, but one I will write. Assumption one is dimension of conductor will remain same. Dimension of conductor will remain same. It is assumption why? Because as the appliances or the conductor is being used in the circuit, it will get warmed up, and because it will get warmed up, the dimension will change. If you remember mechanical properties of solid from 11th class, you know, and also thermal properties of matter, you know that because of temperature there is expansion, sometimes contraction, depending on the material and gradient of temperature. So it will be there, but we are not going to discuss in first case. We assume the dimension constant, so we can make a simplified case. Then that case is enough for all the questions in mains or even in advance in any category for anything we are discussing. But we shall discuss what will be the actual, what will be the case or what will be the output when we don't consider it to be constant, we consider it to be a real case scenario. Then how shall we compute the variables and all the aspects, that we are also going to discuss in the session. So if you assume less than A to be constant, even though it is not constant, the only variables you can have is, the only variables you have is what? Variables affecting R will be your what? C. Your R affecting R will be your what? C. Mass of electron cannot be changed, and length we have taken constant. Electron charge will not be getting affected. It will get affected by what? Free electron density and tau average. These are the terms which will get affected, right? Only these terms will get affected, and if you have the knowledge of the chapter, these are the factors which can decide whether it will be conductor, or it will be semiconductor, or it will be insulator, right? Okay. First we shall see, if these are the variables, how these variables are going to get affected. So assuming another case, in the same case we will assume the another case. If material is of, or material is elemental, for simplicity we are assuming elemental, that means each specimen of the material will remain same. That means the nature of material will not be variable from different section. What I am implying is, there is no impurity in the conductor, so N and A will get only affected by temperature. If there is no impurity involved, so it will only get affected by temperature. And how shall it will get affected? I'll remind you, for each material there is what? We have discussed, for each material there is something what? This is your what? Valence band, and this was your conduction band, and the gap between them is what? Forbidden energy gap, right? See, how can free electron density, how it can change? It can only increase or decrease. What happens here is, if you have any material, depending on if you remember the classes, I have already told you that only electrons in conduction band can cause conductivity or can cause conductance. So to have more conductance, you need more free electron in that band. And how you can have more free electron in conduction band? If you increase the temperature, what will happen? If you increase the temperature, what will happen? You will have more energetic photons. And these photons will do what? These photons will knock the electron from there and it will send it to conduction band. Right? So what I am saying, if temperature you are increasing, then free electron density will also increase. There are other ways to increase free electron density also, but that involves doping. That involves mixing the element with another material. But for now we are talking about the material being elemental. That means only way to change the free electron density is to change the temperature. So on increasing temperature, more electrons gets knocked by the photons and they go to conduction band. That means number of electron in conduction band increases. That means number of electrons in conduction band increases, which increases free electron density further. Remember, free electron density was number of free electrons per unit volume, and free electrons are only electrons in conduction band. If this is conductor, then the gap between them will be very small. So that means with very small amount of energy, there will be many electrons in conduction band. And if you remember, for conductor, already free electron density is in 10⁻28. Okay. Another factor is if you remember, another factor means another variable here is tau average, right? So if you talk about tau average, see, remember, whether you connect it to a battery or not, the electron is always going to move in random direction, right? They are always going to move in random direction. If they are always going to move in random direction, what will happen here is, sometime I will also give you some info about KTG all, because there are few questions which is related to KTG directly implied in this sort of question, but for now we are preserving it for upcoming classes. So if there is a conductor and there is some temperature up above the 0 Kelvin, let's call it T1, and here T1 is more than 0 Kelvin, then what will happen? We know electrons are going to move in random direction. And if you know a little bit of states of matter idea, you shall know the total energy of gas particle we have considered only to be its kinetic energy. So it is not, hold on. It is glitching, hold on. ग्रुप तो किया था तो okay, wait, I'll show you. So if you have conductor and if you increase the temperature from T1 to T2, assuming T2 is more than T1, what will happen? That means from this to this point you have increased thermal energy, and that thermal energy will directly convert into average kinetic energy of electrons. That means the average kinetic energy of electron here, if I write kinetic energy average here, and if I write kinetic energy average here, this kinetic energy will be more than the previous one. That means electrons are going to move more rapidly, and because of this increased speed, what will happen? The time taken to collide between the two successive or one successive collision will get shorter. Means if the electrons are moving with less speed, they are going to collide with, let's say, T1 time. But here, if they are going to move with a little bit of higher velocity, with little bit of higher speed, they are going to collide more frequently. That means if I write here tau average 1, and if I write tau average 2, what you will find, because it has increased kinetic energy, these are going to move more randomly. So you will find that tau average here will be lesser than the tau average there. It is pretty obvious. You can imagine like this: if someone is blindfolded in a room where there are many pillars, you can say, or after each fourth step in any direction there is a pillar, and so on. So if you have sent one person blindfolded, and he or she is moving with gently, he or she may get collide with one pillar, two pillar, three pillar, but the time taken between the collision will not be that high, will not be very small. But if you send someone who gets panic easily, then that individual will move faster. That means he or she will get collide with pillars more frequently. Same thing you can see here. If you increase the temperature, they are going to move more rapidly, they are going to get collide more frequently. That means the average time will get shorter here. Got it? So what we concluded from these two, that if temperature increasing, we figure out if temperature increases, your free electron density increases, right? And as your temperature increases, tau average decreases, right? Vice versa is also true. I am not writing because it is obvious. And if you remember, what was the previous formula for resistance? We had this formula. We had this formula: mass of electron times length E square Ne. Right? So, in simpler words, from the formula you can see the resistance was inversely dependent on free electron density as well as tau it is dependent on universally. If you increase free electron density, R will decrease, and same will happen here. If you increase tau with, R will decrease. But here what is happening, and as we have discussed, only the material, if the material is elemental, the only factor which can affect what N and tau average is temperature. So effect of temperature on resistance will be just what? The direct effect of temperature on these two, and these two will put effect on R. And as you have observed, as temperature increase, N is increasing and tau is decreasing. So that means each factor is putting opposite kind of effect. That means what I am saying, if you talk about N here, free electron density, we know if change in temperature is positive or temperature is increasing, if temperature is increasing, your free electron density also increases. And from previous relation you can see, if free electron density is increasing, your resistance is decreasing. Means one factor is trying to decrease the resistance. But if you see, if you talk about the other factor, for tau average, what you will see here, that if the change in temperature is positive or temperature is increasing, the tau average decreases. And from the relation above, you know, R is all still inversely proportional to what? Tau average. That means here, if tau average is decreasing, R shall increase. So what I am implying, that on increasing the temperature, one factor is trying to decrease the resistance and one factor is trying to increase the resistance. So there are the two factors fighting with each other, and which will dominate over other? It depends totally on the type of material you have picked. Means if I talk about conductor, it can be something different. If I talk about insulator, it can be different. And if I talk about semiconductor, it can be different. So today we will talk about conductor, and tomorrow we will discuss about all the other material. And tomorrow we will also discuss what will happen if we don't assume the dimension to be constant. If I talk about conductor, I know one thing for sure. The N is free electron density is already very high. It is already very high. It is already very high. So on increasing temperature, and does increases, but because actually it is already high. If you remember, the free electron density for conductor of copper I have told you about, it is about in the order of 10 raised to power 28. It is already so big in number that even if it increases on increasing temperature, which it does, the change will not be that significant that we shall consider about it. See, on increasing temperature, it does increase, but as it is already too high, how big we are talking about? In order of 10 raised to power 28. It is already so high that the change is not that significant to consider. Got it? It is increasing, but it is already so high in number that the change is not significant to consider. Got it? imagine that like this, if it is 10 raised to 28, can you even count how many, can you even guess how many billions or trillions time it is? For reference, you have just 10 raised to 9 zeros in billion, and 12 in trillion you have this. So it is trillion times trillion. Even if you have trillion times trillion, it is still going to be 10,000 more than that. This that big a number, right? Per meter cube. So that big a number. So let's say on increasing temperature, the number of free electrons increases by some, let's say like million, or even maybe some values like even million or billion. Even if you add in this, the effect or the overall will not be that big to consider. Okay, so the other factor is what? See, so what we found out that L is also increasing for conductor, but the effect is not that big to consider. So the only thing left is to talk about is tau. For tau, it is very obvious now. If one factor is not going to put any effect, then the only thing is there to put effect is tau average. So we know on increasing temperature, tau decreases, right? And from this you can see it has inverse relation, right? So on decrease, if it is decreasing, that means resistance is going to increase. So overall what we are saying is resistance of conductor will increase on increasing temperature. And you have seen it if you use phone, it is not that good example, but it works. But if you use phone, like not the current one, even the current one also, if you play games for a long time, then the FPS or the quality of games somewhat deteriorates, because what happens that resistance increases on increasing the temperature. So the efficiency of the device decreases, because there are many watts and many types of conductor has been used to make that type of devices, and so on. You can find for like any appliances which is using any kind of conductor, you will find the efficiency will decrease on time after using for a long time, because temperature is increasing. So overall what happens, the resistance increasing. See, at the end it all has been concluded only after doing the experiment. Means we have already figured out by doing the experiment that we had one resistor, same resistor, two same resistor, and we have already figured out that if two resistor we have, that if it is at T1 temperature, if it is at T2 temperature, and if both resistor has been heated up with the help of some devices, let's say that it has been heated up by 50 degrees Celsius, and let's say it has been heated by 100 degrees Celsius, both are identical. What we found out that in both cases the resistance has been increased. Resistance has been increased. These two were identical in nature earlier, so R1 and R2. Let's say it T1 only. So R2 and R2 dash. So in both cases the resistance has been observed to increase. In that case where the change in temperature is more, it was R2 dash was higher than the R2. So it was already found with the help of experiment. Just we wanted to have a conclusive theory which can be evident for that experiment. That's how we do many times in physics. We do the experiment first, and then we try to make the theory which can comprehend the experiment, which can comprehend the data. Okay, so in next class we are going to discuss about the other two material, and then we will discuss more intuitive thoughts in this. Okay.